Now, let's talk about Euler's contributions to the field of mathematics. Euler, considered one of the greatest mathematicians of all times, transformed almost every aspect of mathematics. He contributed greatly to the fields of geometry, trigonometry, calculus, differential equations, number theory, and notational systems. It is important to mention that Euler was the first to write f of x to detonate a formula and use the uppercase Greek sigma for summation. In addition, he introduced pi for the ratio of a circle's circumference to its diameter, and I for the square root of -1, one of the most important imaginary numbers. Yeah.
Math professor Howard Anton states that Euler was probably the most prolific mathematician who ever lived. It has been said that Euler wrote mathematics as effortlessly as most men read. Euler's identity has been described as the most beautiful equation and the most remarkable formula in mathematics. It is written as e to the I pi plus 1 equals 0. It is said that this equation comprises the 5 most important mathematical constants. These are the numbers 0, 1, pi, e, and I. Furthermore, the number e, one of the most important irrational numbers, was discovered by this successful mathematician. The number is the base of natural logarithms, and its first few digits are 2.71828.
Now we will solve the following problem from our calculus class, which is related to some of Euler's most important contributions.
To solve this definite integral, which goes from -1 to 0, we must first find its antiderivative, which will be 2x squared over 2 plus 4 e to the 2x over 2 plus 2 pi x. This will then become x squared plus 2 e to the 2x plus 2 pi x. Then we use this antiderivative to find the definite integral from -1 to 0. We first plug in the 0, which gives us 2. And then we do the same for -1, and this gives us -5.01. Lastly, we subtract these two numbers and get 7.01 as the final answer.
While this discovery is remarkable, it isn't the only one from Euler. The mathematician is also credited for its trigonometric functions, which are used for the angles that can be related with the lengths and sides of a triangle. These functions are essential for various reasons, like the studying of triangles or the modeling of periodic phenomena. Now we will see another problem from Euler's creations that we saw in our class of calculus, which is related to trigonometric functions. Yeah.
As you can see, in this problem, we will use trigonometric functions like tangent and sine.
To solve this indefinite integral, we must first use the trigonometric identities. These state that tangent is equal to sine over cosine. This way, we can replace tangent squared and we can simplify the problem. We will get sine squared over cosine squared as the denominator and sine squared as the denominator. Thanks to this, we can eliminate the sine squared and be left with 1 over cosine squared. This is also another trigonometric identity that equals secant squared. Once we are left with this, we may begin integrating. The answer is f of x equals tangent of x plus c.